Okay, so yesterday we began talking about things with rational exponents. That's powers that look like what? What does rational mean? Fractions, right? So it's things that have powers that are fractions. Yeah, it's 4 to the 3 halves. And so we talked about how there's two different parts to that power. There's the numerator and the denominator. Which one of those is the root, the 3 or the 2? The 2. And the power is the 3. And so we can write this two different ways. So we're going to break up the power from the root. We can write the power first, which would look like that, right? 4 to the 3. And then the root as a radical looks like this. Okay. That's one way of writing it. The base is 4, the power is 3, the root is 2. So this was the power first. If we write the root first, we write that down, and then the power after that would look like this. Okay. But now there's a key word. So yesterday what we practiced was rewriting like this. But we also practiced going one step further and doing the math. What's the key word here telling me that I have to go one step farther and do the math? Simplify. So that word simplify right here doesn't mean you simply rewrite it. It means you rewrite yes, and then you calculate the actual value. And so we can do that when we're following our order of operations. On this first example, we would do the 4 cubed first for the exponent. And so 4 cubed means 4 times 4 times 4. That's 16 times 4 is 64. And then we take the square root of 64. What'd you get? You got 8, right? And then writing it the second way, where you take the root first. So order of operations you do inside the parentheses first. So you take the square root of 4, which is 2. And then you do the power. And 2 cubed means 2 times 2 times 2, which is 8. Okay. Now this problem was really simple to do either way, all right? But sometimes the numbers get really, really big and harder, and so there's an easier way to do it. What did we write on our notes yesterday? If it starts getting difficult, which order did I tell you to do yesterday? No. Okay, so what I'm asking is, yesterday I gave you a hint. If you want to make it easier, would you do the root first or the power first? Does anybody actually know? You're not just guessing and waiting for me to say yes or no. The root. And why do you think it would be easier to start with the root instead of the power? Yes, it would give you smaller number first off, and then you would do the power on that. Okay? So don't forget about that. If it looks like the numbers are getting difficult to work with, do the root first and then the power. But like I said, in this case, it was easy to do either one. So we're going to I think it'll hear me like faintly, but it doesn't. This is much better. You do what? Um, so I will. So we will simplify expressions with rational exponents. And the goal at the end of the lesson, we're going to run out of time, but my original intention was to be able to do this problem. So look at this problem for just a second. How do you feel about that problem right now? It's a little bit scary, right? So while I'm going through the example problems, I want you to keep thinking about this one. It's written on that board. And just try and think about how you might apply what we're about to talk about to this problem. And then we'll start with this as a warm-up tomorrow when we get to class, okay? All right, so the three main examples we want to work are these ones in the clouds. You see all these things in clouds? But in order to do those, we have to review some other basic stuff first. So we're going to do these two baby basic problems and then talk about how it supports this cloud problem. So in this cloud problem, I have two bases that are being multiplied, and they have fraction powers, right? Rational exponents. Okay. So let's look at some examples, though, where I don't have fraction exponents. Do you remember x cubed times x to the 6, what we do with the exponents there? We add them, right? So the rule when you're multiplying bases is that you add the exponents. So it's x to the 9. Good? We remember that? Okay. But in this problem right here, when we add the exponents, we have fractions. So we're going to talk real fast about adding fractions, okay? And I've made it simple for you. They have the same denominators. So here's an example. If I have 4/5 plus 3/5, what do I have altogether? 7/5, right? What happened to the denominator? Stayed the same. What do we do with the numerators? Add them. So take a second using those two pieces of information and try and do this problem in the cloud. Not the Google Cloud. C to the 2/8 times C to the 5/8. And just raise your hand when you have that done. Thank you. Thank you. Thank you. All right. Thank you. Perfect. Okay. Anybody want to offer their answer as tribute? Yes, that's perfect. So C to the 7/8, because your base is C, you're adding the exponents. They already have the same denominator, so the denominator stays the same. You do the 2 plus 5. That's right. C to the 7/8. So this problem was when we were multiplying this two things with the same base. What's going on in this cloud problem? There's one base. You're multiplying the powers, okay? This is a power to a power. And so what happens there is you're going to multiply those. But since we're dealing with fractions, we're going to review two things. One, here, we're reviewing the exponent rule. This is something we did in the fall. Because so let's say you don't remember, like your exponent laws, you're not going to remember, okay? Here's why they get multiplied together. This means I have 5 m2s. So how many m's is that altogether? 5 times 2. Because this is 2 m's, right? 2 m's, 2 m's, 2 m's. I have 5 altogether. So that's how many m's? 10, right? So that's why when you're doing a power to a power, you multiply them. So when I'm doing p to the 12 to the 3/4, I multiply those things. P to the 12 times 3/4. But here's the thing. Now I'm multiplying fractions. So here's an example of how to multiply fractions. Do you remember how to do that?
Yeah.
Across the top, across the bottom. So this means this example would be 2 times 4 over 3 times 5, which is 8/15. And always check if you can simplify a fraction anymore. This one doesn't, but you always want to check. So then right here on this one, I just told you, I said multiply across the top and across the bottom. But this number doesn't have a bottom. It's 1, right? So then it's, you multiply across the top, right? 12 times 3 over 1 times 4. That's p to the 36 over 4, which is p to the 9. And then on this last problem, don't back up, we're writing down. We can do it, we got this. When dividing, remember I would ask you which side has the most, right? So here in this example, where are the most x's? On top, right? So x stays on top, and you do what with the exponents? Yeah. And so down here, in this cloud problem, where are the most r's? Bottom. So r stays on the bottom, and you subtract the exponents. What's going to be on top, though, if there's no more r's left? 1, right? And so it's 1 over r to the 9 minus 4 over 5, which is 5 over 5. What is 5 over 5? 1, or just, see, we did it. I told you. We'll pick up with the bonus problem for warm-up tomorrow.